So on the whiteboard in class is still a list of the 5 triangle congruence conditions. Some of them we proved. One of them, notably side, 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 we haven't proven yet. But if we see these congruence conditions, we can assert that 2 triangles are congruent. They are in no real particular order. If you've got an angle and another angle and they're connected by a congruent side, we call that angle side angle. That's a valid congruent condition. Also, you can have 2 sides with the angle in between them. That's angle side angle. That is a triangle congruence condition. We can also have side, 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 3 sides congruent to 3 sides in the other triangle. That's a valid triangle congruence condition. Also, kind of related to angle side angle is you can have an angle, and then a non-included side. So if we see in 2 triangles, we've got an angle like of 30 degrees followed by an angle of 60, and then the side that comes off of that, that's 10. And we see that in 2 triangles, 30, 60, a side of 10. Those triangles are going to have to be congruent because this angle, angle side actually becomes just an instance of angle, side, angle. So angle, angle, side, if we see that, that's a valid triangle congruence condition. The fifth one looks like it only requires 2 pieces of information, but it actually requires 3. This only applies if we've got right-angled triangles. So if you have 2 triangles with right angles and their hypotenuses are congruent and one of their legs match, those triangles have to be congruent by hypotenuse leg. Now there are some things that we consider that are not triangle congruence conditions, right? If you've got 3 angles in one triangle congruent to 3 angles in another, that is not a triangle congruence condition, simply because of the fact that those triangles can be scaled up or down. Another one that we considered was side side angle, and the reason why this didn't work out was it turns out that there's possibly two different triangles there. Um, so side side angle doesn't work unless the angle is a right angle, then that just becomes an instance of hypotenuse leg. But if it's not a right angle, in general, side side angle doesn't work. So there are triangle congruence criteria, and there are some things that are not. So one of the things that you had to do on the test was identify which triangle congruence condition could be used to establish that 2 triangles were congruent. And if I was to just kind of sketch some things here, like I could say this, 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 this. That's an awful diagram. That looks nothing like congruent triangles. Let me do this. So let's say, for example, we have these 2 triangles, and it definitely looks like those are right angles, but I'm not marking that, so we're not assuming they're right angles. But let's consider these markings. So if this is what we're shown in our diagram, when I look at it, I can see clearly the side is not connecting my angles. So this is not going to be angle side angle, and I don't have 2 sides with the angle in between. But what I do here have is I have angle angle side. So if you look, I start with the angle with 2 marks, and I'll highlight this one. So that's the angle I start with. Then I roll over to this angle that I'll mark in blue, this angle that I mark in blue. So yellow angle, blue angle, 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 and then the side that I've got marked with the 2 tick marks, right? So this is angle, angle, side congruence. In this diagram, you can see I am given that I've got the right angles, but I don't have hypotenuse leg here because I don't have any information about the hypotenuses. Now, I could assert that the hypotenuses have to be congruent because of the Pythagorean theorem, but that's not what I'm shown, right? What I'm shown is I've got a side, right? I'll mark it in yellow with this side in yellow. I've got the angle, and then I've got the other side. So what we're looking at here is angle, side with yellow, and then the angle that's right, and then the side with blue. So this is side angle side, SAS. So for this particular diagram, it looks like we've got a side, side, and then an angle that's not in between those. So this looks like side, side angle. I said that this is not a triangle congruence condition, And it's deceptive when you look at it because it feels like you should be able to say, no, come on, that has to be one, right? Why isn't it one? Well, let me try and convince you why. Okay, I think I might be able to show this now. If I grab not a ruler, but if I grab the compass tool, oops, or protractor tool, well, it's actually a compass tool, right? So I can use it to sweep out arcs. So if I put this cursor right here like that, so you can see the center of my circle is where those two sides with one tick and two tick marks are coming together. And I'm going to grab this red pen. Oop, not that red pen. I'm going to grab a pen and let me make it kind of this orange color, and that's way too thick, so I'll make it thin. And I just try to sweep out this arc. This might form a compelling argument, and maybe it won't. So here's the problem. If you look at this, all I'm claiming is that I've got this one side, right? We're claiming that we've got this one side, and it's congruent, and that this side is congruent. It has to stay this size. I can't make it bigger or smaller. I can't make that angle bigger or smaller. And this side right here also has to stay the same size, right? I'll highlight this in this green. This thing can't get bigger and it can't get larger. But if you look closely, I can swing this green segment to the right, and when I swing it along, oops, not that. When I swing it along, I end up getting several points I can stop along the way. So like every single time I draw a line from that vertex to there, these are all the same length, right? And you can see that's a problem because they're not hitting that bottom line at the right spot. But if I keep going, there's a point right here, a sweet spot where I'm hitting it again. And you can see the moment I do that, this segment, right, is exactly the same size as it was originally, but because it just swept over there, now I have this new triangle, and you can see there's two triangles. This one triangle that I'll highlight in all green, the larger one, right, this green one, and then inside of that I've got this smaller triangle that I'll highlight in this orange, that's this one. Well, those two triangles have the exact same side, and then congruent angle, but they're clearly different sizes. So this is why side angle doesn't work. It's because when you see that pattern, there's the potential that there could be two different triangles there. And again, if this angle that I had marked congruent was actually that angle was actually a right angle, they actually would be congruent, but I don't know that they're right angles, and that's not given. So, and then I wouldn't be using side angle, I'd be using hypotenuse leg. So these two triangles are not congruent because side angle is not a congruence condition. This is an absolutely terrible diagram, but it allows me to illustrate another point. Sometimes when we have triangles that are touching in some way, as in this case, there's possibly more information than meets the diagram here. And the extra information that we can add to this is the fact that because these angles are vertical angles, they have to be congruent to each other. So before it looked like I just had two sides only, but with the realization that I have a pair of vertical angles, I can say these two triangles are congruent by side angle side. They meet the side angle side congruence condition. This is another variation on that. And although these triangles are actually not congruent, if they were drawn and the information I gave on them was correct, that the two lower sides were congruent and the sides on the left and right were congruent, they would have to be congruent by side because they share this side. And one of the things we know is that a length is equal to itself, and a segment is also congruent to itself. So we would meet the side condition here. So again, these triangle congruence conditions and some of these other things we talked about, particularly involving alternate interior angles. Well, I was going to say vertical angles and shared side or the reflexive property are here, but also on the board in the classroom was the fact that if we're given that we have a pair of parallel lines, that this parallel line though, if these are indeed parallel lines, they produce some congruent angles. So maybe I've got some triangles that are built. Um, I don't know. I could say it like from here to here. Maybe I've got this. Oh, that's awful. This transversal, but I don't even want to. I don't even do. If I'm told that this segment, now it's just goofing around. I'm going to stop at that. Um, just remember that the fact that if you've got some parallel lines cut by a transversal, it does produce some congruent angles, and those congruent angles perhaps could be part of triangles also.